So today I'm going to talk about how to use WestGrid. Last time you learned more general information about how WestGrid works, and today I'm going to get down to more practical aspects. So WestGrid mainly consists of various clusters located at different sites, as you heard, which means that we work on a batch system. These are machines where you're sitting as a user here at your desktop, and you would connect to a WestGrid login machine or a head node. The head node sits in front of a cluster of machines where all the work is done, and you may have attached to these a shared file system, so all the files that you have are accessible to any of these compute nodes. So as I said, all the work that you do on these systems are batch systems. So you would submit a job, the jobs are queued, and they're run when the resources become available. The priority of your jobs depends both on allocation and past usage of the resources. So for example, in Jasper, we have 240 nodes with X5675 processors, which have 12 cores per node and 24 or 48 gigabytes of memory, and 160 nodes, which are older machines, with 8 cores per node and 16 gigabytes of memory. And they're connected, or it's served by a Lustre distributed file system consisting of 256 terabytes. And the cluster nodes are connected through a high-speed InfiniBand interconnect. Other clusters on WestGrid have similar characteristics. Some of them are very special and quite different, but most of them look like this one. Today, I'll be talking mainly about Jasper, but most of the concepts apply to any of the clusters in WestGrid. I should note that every site in WestGrid is different. They work in a similar fashion, but every site is different, so you're encouraged to look at the quick start guides for each of the sites before working on a particular machine. So the first step you need to do is choose which WestGrid system you want to work on. There are certain sites which are specialized for certain types of jobs. For serial jobs, you can run on Bugaboo, Hermes, Jasper. OpenMP parallel jobs are rather special because all the processes have to run on the same node. We've recently added Jasper to use whole node scheduling, so that now you can run OpenMP parallel jobs in Jasper, Breezy, or Hungabee. There are also other sites being set up this way, so that this information will change with time. For MPI parallel programs, you can run on a large number of sites: Bugaboo, Grex, Jasper, Lattice, Parallel, Nestor, Orsinus. We have one special machine equipped with GPUs that's parallel, located in Calgary, and you can also use it for visualization as well. We have two large memory machines, Breezy and Hungabee, and so these are used where you need a lot of memory, but also note in addition they can also run OpenMP parallel job. And finally, we have Grex, which is specialized for running Gaussian programs. So the first step in connecting to WestGrid is you need a program to connect to it. On Linux and Mac systems, there's a program called SSH, and you can connect to it with a command that is this. So the -y flag allows for graphical use. Then you would put in your WestGrid ID and jasper.westgrid.ca. On any of the machines you connect to, you have a limited interactive use of the machines. As I said before, all the jobs that you run should be run through a batch system, but you can do certain things interactively that's you're just typing on the terminal. So you can compile some testing and debugging. On Jasper, we ask people to use less than 1 hour in 2 cores. If you need a longer interactive use, there is a special interactive batch mode. You can start with QSAT minus capital I. I'll talk a bit more about that later. For Windows, it's a bit more work to get things set up to connect to WestGrid. You should install a terminal program such as PuTTY, which you can download from this link. And you should also have a program to transfer files, and the one we recommend is called WinSCP, and the download link is given here. In addition, if you want to do any graphical work, you need an X Windows server, and that one you can get is called Xming-Mesa. You can also, there is a version called just Xming, but for some things you need the Mesa version. So I'm just going to, oops, that shouldn't be, go back. Okay, did do it this way. Right. Oops. Sorry about that. Okay. I'm just going to start through the steps for a Windows user for doing all these steps. So after you install Xming, you can start it by double-clicking on the icon. You see, I managed to screw up some of the labels. So this is the icon that you would double-click on. It would start up, but you won't really see very much when it starts up. You just see a little icon show up on the I guess this is called a taskbar, a little X that shows up. And that's all you need to do about starting up Xming. For PuTTY, before you, when you start up PuTTY, you get a configuration window. And one of the things you should do is go to under SSH category, there's an X11 subcategory, and you should enable X11 forwarding here. And once you do that, you can put in the host name, jasper.westgrid.ca, for example, and you can save that session. Here I've saved it under the name of Jasper. And once you save it, you can open it, and then you connect to Jasper. And you get a window like this, where you would put in your username and the password, and it should log you into Jasper. One of the things you can do to check that the Xming is working is to type xclock, and it should come up with a little clock on your desktop. So these are the steps you would do to log in. I'm just going to go through steps of moving some input data from your own computer to Jasper, in this case, and run that job. So first, once you log into Jasper, you can make a directory called with an mkdir command. So you can make a project1 directory. cd is a command for changing to that directory, so you can move into that directory. Now, we want to now transfer some files into that directory. So you go back on your desktop, And from a Mac or Linux machine, the command is you can use is scp. So you can scp whatever file you have on your desktop, and then you give your WestGrid ID at jasper.westgrid.ca : that will put the file into your home directory, the directory that you log into. If you want to put it into some other directory like project 1, you would add project 1 here. Alternatively, you can install, there are programs you can install on a Mac or Linux, like FileZilla, which allows you to do this in a graphical way. On Windows, the recommended way, as I said, is using a program called WinSCP, and it's a graphical program. And here, basically, you just drag and drop a file from this side, which is your desktop computer, and to the folder or directory that you created here. So I'm taking a file called magicsquare.m and going to move it into the project 1 directory. And so that transfers the file from your desktop computer to Jasper. Now, once you have your input file on Jasper, you need to make a batch script to run your program. In this example, I'm just using a MATLAB job file. MATLAB is a commercial program, so it's not available everywhere on WestGrid. Here at the U of A, we have a local license, so people at the U of A can run MATLAB on Jasper. Other places also have their local license, so they can also run MATLAB on their machines. But it's not available everywhere. So first thing in making a job script is to edit it. And I recommend that you learn to use an editor on Jasper rather than making up such files on your Windows machine and transferring it, because there are often problems in doing that. So here I'm using a program called nedit, and I'm just calling my file job.pbs. And these are the things that I type into my job script, which I will explain a bit more in detail. But basically, all the lines at the beginning starting with #pbs are requests that I'm making to the batch system about the resources that I require, and the email notification I want sent. And then I have commands which basically change directly to where I submitted the job. We'll talk about modules later. And then I have a MATLAB command that uses that magic square file that I sent over. So once you make such a file, I hope everybody can see this. In case somebody has trouble seeing some of the slides, the PDFs of the slides are available on the WestGrid website where this seminar was announced. So you can always have a look at it. So basically, you would submit a job with a qsub command. So you would say qsub job.pbs. That submits the job, returns you with a job ID number, which is useful to have in case you need to track it. But otherwise, there's a command called qstat that allows you to monitor the jobs. And in this case, I specify -u Fujinaga to see all the jobs that I have, and it just lists the jobs. Initially, you would get the job listed with a status Q, meaning that it's being queued. Eventually, that status will change to R, meaning it's running. And then when it's done, it would stay in the C state for complete for a short time, and then eventually it will disappear totally. So once it's done, you can look at the results. And I find it useful, the command ls, which lists files, with the option -lrt, which lists files in the reverse chronological order. so that you see that at the bottom, the files which are most recent. So here I see that running this job created a file called job.pbs.0509857. So what it does by default is to create a standard output file with a job name, which in this case is just the name of the file, .o, and the job number. And there will be a corresponding standard error file with an E in place of an O. So these are files that you should always look at. Hopefully the .e file is empty, meaning that you've had no errors. So this is the output that I got from my run, and I used the more command to look at the file, which gives you a page full of the file at a time. You would use space to get another page and Q to quit. So that was a sequence which should be similar for most people, that you would transfer some data from your own desktop computer to one of the WestGrid machines, create a job file to run your program, run the program, and then look at the output. Here I've listed some basic Unix commands that you may find useful. ls you've seen, lists files and directories. cd, change directories. Print working directory, sometimes you get lost where you are, and so sometimes you may find it useful to print the working directory, that's where you are. More, sometimes called less. Less was an improvement on the more, which was the original command. Now they're the same thing. The less and the more are, in fact, the same program. Cat is another way of looking at files, but this one prints the whole file all in one go. Man is an online manual. So if you have any problems about, or if you want to know more about any Unix command, man is the command that you should use. Make directory using mkdir, rm for remove, removes files and directories. cp for copy, mv for move, or basically it's a renaming command. Exit or log out will allow you to finish your session. Sometimes, depending on the way it's set up, Control-D also works. Control-C is an interrupt, so if you start something and it's just hanging, or you want to cancel it, you would type Control-C. So as I said, man is the documentation, the official Unix documentation for these commands. And so you would type man and the command name. And here I've done man ls. And the output is like a more command. So you would get a page full at a time, and you can space bar to get another page. You can type slash and whatever string to search for a particular term, so you know what you're looking for in a command. You can search for that string. And if you don't know what the command is, you can type man -k and whatever the command that you're looking for, and that will give you a list of man pages which are related, which have that term keyword. So that's a way to find new commands. Okay, setting up the environment. Most WestGrid systems use something called modules to set up user environments. And so what these modules do is to set up environmental variables, basically, such as path, which tells the system where to find programs, or load library path, which allows the system to find libraries. And you can, on any WestGrid system, you should type module avail to see the available modules, and you should do that on every system because every system has different modules. On Bugaboo, many programs are already in the default path, so you may not need to use any modules. On others, some modules are loaded by default while others are not, or on some sites, no modules are loaded by default. So to see which modules are already loaded, you can do module list. Just to give an example of what you get on Jasper, there's actually a large number of modules, and we've organized it according to categories. So all the applications start with application, and you have some compilers, libraries, utilities, and then at the end we have some modules that are specific to U of A users. So these are basically licensed programs that only users, U of A users can use. I want to talk a little bit about file systems. The directory where you log into is called the home directory. In most WestGrid systems, there's another directory called the global scratch where you should do all your work in, because these are directories where you have a much larger quota than the home directory. On some sites, you may have to create your own directory within that global scratch directory. On other sites, it's already made for you. Where on WestGrid sites where there is a home directory and a global scratch directory, which I guess is almost all of them, the home directory is backed up, whereas the global scratch directory is not. The couple of systems where you don't have the two sets of directories is on Jasper and Hungaby, where there's only the home directory, which means that it has a large quota, like other global scratch space on other systems, but it is not backed up. You can check. Different WestGrid sites have a different command for checking your quota as well. So you can look at the quick start pages for a particular system to find the quota command. And that, so related to this topic of quota, you may find that you have reaching a quota on one of the systems that you're working on, and so you want to move some of that data off that site onto storage. The main storage site is called Silo, and that's where most of the data is stored. And there are a couple of utilities that are useful for moving data over there. One is called GCP, and that behaves somewhat like the SCP command that you saw earlier, that you specify the file name and then the destination. There is another way of transferring files, which is called the global file transfer, and this one is very nice because it can be set up. Oh, I should mention, go back. The GCP only works within the WestGrid system. So if you want to transfer files to your own desktop, this doesn't work. Whereas global file transfer, Globus file transfer, can be set up on any computers, including your desktop. And so you can start a transfer going between a WestGrid machine and your desktop, for example. And the nice thing about it is it's fault tolerant. So if there are problems with network issues, it will recover and it will start again when the network is working again. Okay. I want to talk a little bit about software. The software that we have on WestGrid is listed on our website. And once you go there, you get a page like this with a list of software. You can choose software category to limit your the software that you get listed, or you can even, if you're looking for a particular software, you can put it into the search field. And for each software, you can get a list of software versions listing you on which machine, WestGrid machines, the software is installed, and some instructions about how to set up the environment to use that software. If there are software that's not listed on our WestGrid website, you can install your own in your own directory. Or if you're not comfortable with that, you can always request installation, and the people responsible for a particular machine can install the software for you if it's freely available. And as I mentioned before, for U of A, there are some special software that we've installed on Jasper and Hungaby. For other sites also have specialized software that install only for their local users as well. Okay. I'm going to move on to compiling. Okay, so we have various kinds of programs that you may want to compile. So the first thing is to load the module. So in this, so here I'm loading the module for the Intel compiler on Jasper. The compiler is called ICC for C compiler, or iFort for the Fortran compiler, and you would compile the program as shown here. And running the program, you would often need to put a // at the beginning of the program name. Oh, this is because of this environment variable called path, which allows the system to find programs. And usually, unless you define it as such, the current directory is not necessarily in your path. So when the system goes to look for a program, it won't find it if it's just in the directory where you are. And the // annotation points to the current directory where you are. So in this case, the program is run just by /hello. That's the name of the program that I've given it in a compilation command. For OpenMP programs, it looks basically the same. You would give an output executable name, the name of the source code, and a -OpenMP flag. And to run it, you would need to define an environmental variable called OMP num threads to be the number of threads that you want to run, and then you would run the program. For NPI programs, steps a bit different. You need to, in addition to the compiler, you need to load the MPI module. So in this case, the OpenMPI, which is used mainly in all over WestGrid. The compile command is now called MPI-CC or MPI-F90. And to run the program, you would run it with an MPI exec command with a -NP for 2 processes. Now, these are all examples I'm giving for interactive use. Okay. For editing, for most users, I would recommend graphical editors such as NEdit. Sometimes there's one called gedit. There are non-graphical editors on Unix. The common ones are called VI and Emacs. But the use is rather complicated, so there's a rather steep learning curve for using these editors. The advantage is that you don't have to bother with the graphical interface. You can also edit through WinSCP. That is, you would edit a file on the Windows system. So you can actually double-click on any text files in WinSCP, and it will open up an editor in Windows. But it's really not recommended because there's a difference between DOS and Unix text files, and so the transfer doesn't always occur properly, and you have to fix it up on the Unix side anyways. So I would encourage everybody to learn to use a Unix editor. Okay, so back to running in batch. So this is for a serial program. So the first couple of lines in this here in this script you should always have. So that just tells the system what kind of shell to use. Shell is a sort of a environment you can have in Unix. Most common are Bash or C shell. And most, I think the default shell that you get when you apply for WestGrid is a Bash shell. And all the examples that we have on our website are Bash. So I would encourage you, unless you have other needs, to stick with the Bash shell. So this line, PBS-L prox equals 1, is asking the scheduler that I need one processor. The next one, pmem equals 2,000 megabytes. The P refers to the per process memory, so it's 2,000 megabytes. And it's a good idea to put in 2,000 megabytes than 2 gigabytes because sometimes you have problems because of the way that the system requires some memory. Even if the Jasper nodes have 24 gigabytes of memory, for the batch system, you don't have that much available. So it's better to use multiples of 2,000 megabytes rather than 2 gigabytes. The wall time is the total time of the clock on the wall that you have for the job. So this, in this case, is 5 minutes. The next line tells the batch system that I want to be notified by email when it begins, exits, or aborts. And this is the email address that I want my notification sent to. So all these lines starting with PBS are commands or requests to the batch scheduler, and they should come before any Unix command that you give. If you put any Unix command in between here, all the remaining the PBS commands will be ignored. So make sure all these lines are at the beginning. Now this line, CD $PBS O work here. There are various variables that are defined by the batch system, and they all start with PBS. And this one refers to the directory where you submitted your command, the batch qsub command. So this automatically changes directory to where you submitted them, which is normally where you have all your data files. So this is also a line that you should always have in your script. Rather than typing in the actual directory name, if you just have this in here, you can move this script around and use it from other places without having to change the directory name. And here again, I'm just executing the hello program. And so here, I go through the qsub command. You would just say qsub and the job script name, get the job ID back. You can use qstat to monitor when it's queued, when it's running, when it's completed. Okay. So as I mentioned before, you can also have an interactive batch job. In this case, you would submit a qsub command. You would do a qsub command with a -I. The other parameters can be as in the file that I showed you with a -L, prox equals 4, pmem equals 2000 megabytes. For interactive batch jobs, there is no script, so you just need to specify that your resource requirements with the -L. Now this, depending on how much resources that you ask for, this may sit in the queue for some time. So be prepared to wait. And once this job is ready, then you can start. You will be logged on to the machine that it assigned you to, and you can do all your interactive batch job there. If you have graphical programs to run in that session, you should add a -X. And that allows you to have graphical programs. You still have to have an X11 server working on your own machine, like Xming. So for OpenMP batch jobs, it mainly looks the same, except now instead of in the serial jobs, I had prox equals 1. Here I have nodes equals 1, colon, ppn equals 4. What that means is that I want 4 processes all on the same node. So an OpenMP job requires all the processes to be on the same node. So that's the way you have to ask for your resources in an OpenMP job. And otherwise, it looks the same as in the interactive case. You would set OMP num threads to the number of threads. You can put in 4 here, but an easier way is to use another variable defined by the PBS, the batch system, which is PBS num ppn, which just basically takes that number that you specified up here and puts it here. And then you can run your program. For an MPI batch job, on many of the system, you can just specify number of procs equals 4, for example. And everything looks almost the same as in the interactive case, except now I have MPI exec and just straight the program name. I don't have a -np equals 4 because the batch system takes that number that you specified up here and creates basically a -np4. I should mention that the prox works in most cases on some machines for MPI batch jobs. You should not use prox. On Parallel and Lattice, they're strictly a whole node scheduled machine. So there you need to specify with nodes equals whatever number, colon ppn equals 8 or 12. Similarly, on Jasper, as we switch to whole node scheduling, that's the way you should be specifying the resources. Okay. Since I talked a little bit about MPI or parallel programs, I should mention that benchmarking is a very important part of running parallel jobs. You should time your program with different number of processors to make sure that with additional processors, you're actually getting a faster program run. So for doing a timing, you have to make sure that it's reproducible, that you have no other users on the system. So again, you need to ensure that the system that you're doing the timing on, you reserve the whole node. And you can use the time command and look at the wall time to see whether you're getting a speed up when you're running a parallel program. Even without having well, I want to mention a little bit about profiling because this is also part of optimizing your runs. And there are utilities that allow you to get a profile of your running job to see which part of your program you're spending a lot of time. And one way to do that is to, when you compile your program, to add a -PG flag. And then you would create a job to run that. And when you've run that, it creates an output file called gmon.out. And you can use another program called gprof to look at the output. And it will give you a breakdown of how much time you're spending on each of the subroutines in your program. And that way you can try to optimize the part that it's spending a lot of time on. And so it looks something like this, and it gives you time, the percent of time spent in each of the sections. Some of these are system routines, so that you can't do anything about. But here I have 3 routines called, or 4, mmul, xsweep, zsweep, y-sweep, and it tells you how much time it's spending on each of them. And as you optimize your code, you can see how much improvement you get. One way to get quite good optimization is just to use the compiler optimizations. These are fairly powerful ways to speed up your code. And so in most cases, the default is a level called -02, and you may be able to get higher optimization with -03. And these are special flags for using coprocessors, basically. Or no, they're not called coprocessors. I forget what they're called now. Anyways, and don't have to worry about the exercises. This slide was taken from another workshop that we gave. So anyways, you can play around with various optimization levels and see how your program changes. You have to also make sure that the answers that you get as you change the optimizations are the same, because sometimes they will be different. Some of the higher optimizations get higher speed by sort of cheating on the arithmetic that they do. So if that difference is important to you, then you should maybe back down, or there's a special flag called FP model precise that may give you the same sort of precision. Another way to optimize your code is to use optimized libraries. With the Intel, you get something called the map kernel library, and in order to, so this has library routines for doing linear algebra and FFT and such things, and you can turn it on with a -MKL flag, set the sequential on our systems. Okay, how are we doing? That's about all I have today to talk about. The most important, though, is how to get help. There is quite a bit of information on our WestGrid website. I find it most useful to use the search function. So if I want to know about Gaussian, I would type Gaussian in the search field, and it will, one of the top hits will be the Gaussian page. Another way is just send us email to support@westgrid.ca. And when you do that, please make sure to specify your user ID, which WestGrid system you're working on, your job ID, error messages, and where your script is. The last point, we would like to know where the script is rather than what's in the script, because sometimes the script file itself is the problem and not the content. So that's about it. If there are any questions.
Yeah, we have a question from University of BC, Okanagan.
Hi, I just have one quick question regarding the FileZilla, because I have been using FileZilla for my Windows computer. Is there any restriction for that using in the Windows computer?
No, it should work fine. If you have any problems using it, just send us email to support@westgrid, but it should work fine. FileZilla.
Yeah, it's working.
You don't have to use WinSCP. If you have something else that works the same way, FileZilla is fine.
Okay, thank you.
I was wondering, you mentioned that different universities had different software available to them. How do you find out that information?
I guess, well, as you've seen on our website, we have labels U of A attached to the modules. I know that some of the other sites have the same sort of system, but not all of them. So if you're not sure, you can just send email to support@westgrid, or the way that our modules are set up. If you try to use the module and you're not allowed, then it'll say so. There are some softwares also where you have to agree to a license agreement before you're allowed to use that software. So again, if you try to use something, it doesn't allow you to use it. You can email support@westgrid, or you can look on our website about that software.
Okay, thank you.
Other questions? So as I said, the slides are up on the website if you want to look at it. I encourage you to go through the basic exercise of transferring files and creating a batch script and running your job.
I have a basic question about the use of memory and defining the memory when you're submitting a job. I was just wondering, how do you basically decide on how much memory to use if you're using a program for the first time with a data set?
Well, if you don't know anything about the program, I would start with a PMEM of 2,000 megabytes and see, because most of the machines we have on WestGrid have about 2,000 megabytes per core of memory. So that's sort of the amount that's normal. So I would start with that. Make sure to put your email address in the job script. That way you will be notified if your job fails due to not having enough memory. And it will also tell you how much memory you've actually used, even if if it doesn't fail, it tells you how much memory it used.
I see. And then you can use that information next.
Yeah.
Okay.
Yeah.
We have a question here, Masao from SFU.
Okay.
Go ahead.
Yeah, I would like to know if a program can be interrupted if it's taking too long. Like if you guys can interrupt the program if it's taking too much time.
Sorry, can you repeat that again?
So, like, if I launch a program, maybe it's going to take 2 weeks, or I don't know how.
Oh,
can you interrupt?
you want? If you mean if you don't like the way your job is doing, there is a command called qdel, which.
Are you saying your route for how long the job will run?
Yeah, and
you can provide a rough estimate, and if it's close enough, we can change the time. We can extend.
Sorry.
That was okay?
Yeah, it's okay.
We can follow up here afterwards.
Yeah.
Oh, no more questions? Well, thank you very much for coming.